by the Volksforschung Austria Research Institution of Vienna, which we also work together with some projects. Yeah, my today's topic is the humidity surcharge, so the impact of humidity on natural fiber materials. And first, I want to give you a short introduction to our research area. We are a quite young research area. We exist since 2019, and our objective is the increase of the market share of ecological building materials in the construction sector. And we have three research areas which we focus on, which are ecological building materials and constructions, building greening, and smart and green cities. And we have about 15 members in our research group. Here you see some more, but some of them are not working. It quit already, so it's changing quite much. The presentation will be divided in one introduction section at the beginning, and then I would like to present the results of the Natureplus research project, which I was involved in. After that, the ThermNat research project, which was led by Volksforschung Austria. And if there is still some time, I would give a short introduction into research projects that we plan to do. Just they are still in preparation phase, so they have not started yet. About the ecological natural fiber materials, generally insulation materials, if you want to assess the ecology of insulation materials, you have to consider what they are made out of, what's the sources, how they are produced, how they are used, and how they are disposed of at the end of the use phase. And the best case would be if they are made out of natural materials, which are the already mentioned natural fiber materials like hemp, straw, flax, and so on. And in the production, they should not use too much energy. And in the using phase, they should still have a good insulation function. It should keep the heat in the building, have a very low thermal conductivity, and in the best case, they can be reused after the end of the life as the same product or recycled to a similar product. About the requirements for thermal insulation, we all know that in the past buildings were not insulated so much, and in the last years, like you see here for the case of Germany, it's similar for Austria. The requirements have gotten stronger and stronger, and nowadays buildings use just about 10% of the heating energy demand like 50 years ago. So the insulation topic has become more and more important, and nowadays we are constructing buildings with so thick insulation that they might not have to be heated anymore like passive houses. What exactly is insulation? We talk of the same thing. Insulation is a material that is preventing the thermal conduction inside the constructions. So there are three possible ways of heat, of how heat can be transported. It can be transported through radiation, like from the sun, through convection, like you open the window and the air gets out, or it can be conduction through the building, through the whole construction. And this is what we focus on if we talk about insulation. And in detail, an insulation material has a thermal conductivity of less than 0.1 watt per meter in Kelvin. And the usual, the common value for calculations is 0.04, which is a value that also natural fiber materials can accomplish. If we want to classify insulation materials in the categories of the raw material, there are four categories, like fossil insulation materials like APS, XPS, the mineral insulation materials like mineral wool, glass wool, rock wool, and then the category of the regrowing natural fiber materials and the recycled materials. And we, if we talk about the natural fiber materials, we are in this regrowing section, which has the lowest energy demand in the production. And now to come to the topic of humidity and the impact of humidity on the thermal conductivity of insulation materials. We have to know that there are two different kind of values, which is the declared thermal value, Nennwert, and the design thermal value, Messungswert. And the declared thermal value is the value that you find in product declarations, which is good for comparing products within the insulation group, and for building physics calculations, you use the design thermal value. And this design thermal value is usually worse or not so good value, not so good insulating. So it's a higher thermal conductivity because it's measured at a higher moisture content. Declared thermal value is measured at 50% and the design thermal value at 80% moisture content. And there is a conversion factor. If you want to get to the design thermal value, you can take the declared value from the product declaration and use a conversion factor to come to the design value that you have to use for the calculations. And this conversion factor is quite important for us because this is for what we see on a later page, which is quite high in Austria for natural fiber materials. And why do we need this conversion factor? Because, like we see here, if the water content inside the thermal, the insulation material gets higher, then also the thermal conductivity is increasing, which is not what we want. We want a low thermal conductivity, good insulation. So we should keep the insulation as dry as possible. Just for calculations, we have to calculate with this value for 80% relative humidity. which is a quite high humidity. So it's basically the worst case scenario. And here some results for isocell cellulose fiber insulation, where you see that if you increase the water content from dry to 90%, the thermal conductivity is increasing by 5% as well. So you have to keep this in mind. And some other results for cellulose fibers and wood chips insulation materials show similar results. So if you increase from dry to 80% relative humidity, you get an increase of thermal conductivity by 6 or 9% in those two cases. So these were just some measurements that were done in the past. And in the standards, it's there are different rules or different definitions in Germany and in Austria. In Germany, DIN 4108 part 4, there is a distinction between hygroscopic and non-hygroscopic insulation materials. And for the hygroscopic insulation materials, the factor is 1.05. This additional factor that you have to use if you want to come to the design term value. And for non-hygroscopic insulation materials, it's just 1.03, just 3%. So the factor is 3 or 5% in Germany, depending on the type of insulation materials. And the natural fiber insulation materials are usually hygroscopic insulation materials, so they have a 5% moisture surcharge in Germany. In Austria, though, the result, the situation is a little bit different. There's a distinction between synthetic and natural fiber insulation materials and also some other types of insulation materials. And for natural fiber insulation materials, there's a 20% moisture surcharge, which is quite high, and in many cases higher than necessary, what you will see. Here the other possible values out of the Austrian standards, and on the right side you see the 20% value surcharge, 1.2 factor, and the factor 1 for synthetic insulation materials. And here the definition in Germany one more time. And here there's another definition in the standards, in the German standards, where is a distinction between synthetic insulation materials and other sheep's wool and other natural fiber materials, which is also a quite low value here, from 2% to 6%. And there have been some measurements already about this moisture surcharge for wood fiber insulation. And here you can see the results with 20% moisture surcharge. This would be the thermal conductivity depending on the density. And the measurement was somewhere here. So the measured value was much better than what it would be with the 20% surcharge. So this results give some doubts if it's really necessary to use this high moisture surcharge, and or is if it's maybe not necessary, or if the value should be adapted in some way in the standards. And now I would like to present some results and some activities from our Natureplus research project. And in this project, we also made some measurements on natural fiber materials. And also, I want to present the results of these measurements, which will show the moisture surcharge that we did measure for these materials. In general, we did examine different natural ecological insulation materials, and we also made a homepage where all these materials can be found, and there is an explanation about about these materials and their properties. And materials for insulation, materials for interior design, like clay and lime, we also examined, and they can also be found on the homepage. And why was it necessary, or why did we want to do this project? What was the reason? We can see in Austria that the share of the construction industry on fossil energy use is more than 70%. So it's a quite high fossil energy use in the construction sector, but is due to the use of not natural but fossil insulation materials and the use of concrete, cement for concrete production. Most of the new buildings in Austria. And why? We were thinking, why is the use of natural fiber materials, natural building materials still so low? And we found out that there are reasons like lack of information, lack of knowledge, specialist knowledge about the connections, details, and combinations of the materials. And we wanted to assess these problems with a big network of specialists in the field of natural construction and natural materials. That's why we initiated this project, Natureplus, and it was funded by the FFG, the Austrian Research Funding Association. And we were a big network of about 20 partners, companies like architects and material distributors and producers, and some the IBO and we as academic partners as well. Here a picture of the team, and our goals were to create an overview of the existing ecological designs, to develop new constructions, new designs that are fault tolerant and that use ecological building materials and just ecological materials, no fossil materials. And we also did digitize these constructions that they can be used by architects. And we did create an online planning tool for this that can be found on our project homepage, www.natureplus.at. And last but not least, we established a network of regional experts in this area of green building. And we are still active in this network, and we are about to start new projects to continue on this topic. And in this project, we made many workshops. We were working quite closely together, and, discussing the main points of ecological constructions that they can be used in buildings with 4 or more floors. So in higher buildings, also in Vienna, which would be our goal. And in the end of the project, we managed to finish this homepage where the constructions that we developed are free for download and can be used by architects and other planners in the planning of for or in a high building in out of ecological building materials. So not just a single family house, but also in higher buildings like 4 and 5 floors. Here on the homepage, you can find building materials, superstructures, and component joints, and all these out of ecological materials like that I showed before. What were the measurements that we did in this project at TU Wien? The most important that I want to show is the so-called stress test, where we did measure the fault tolerance of ecological insulation materials, especially for straw, cellulose, sheep's wool, and mineral wool. And we made also measurements on existing buildings like the House of Learning, which is a building insulated with straw bales in St. Pölten in Austria. A single family house, Klammengasse, which had a water damage and it is insulated with sheep's wool. So we wanted to examine the sheep's wool insulation after the water damage. We also made thermal conductivity measurements with different blow-in technologies for straw insulation, which were blow-in in standing position, blown in a lying position, or blown in the second time after taking it out and blown it in again. And in the end, we also made some mold tests on insulation materials, where we also used the wet or the damaged insulation from Klammengasse to examine the mold risk after some years. And yeah, here you see this water damage area in Klammengasse in the one family house. And from here we took some probes for the thermal conductivity measurements and also the mold measurements, mold tests. And we made in situ measurements at the House of Learning, like also to check if, on the one hand, if the thermal conductivity of the straw bales is still what it should be after some years, or if it got worse, but it didn't. And if the straw bales are still functional, still good under the green roof. So we had here a green roof that was also insulated with straw bales, and it also worked well. Here you see our test bench at TU Wien on the Arsenal campus, where we were making the measurements on the ecological constructions. So in this building on one side, we did insert 4 different insulation materials in this department. So we did we had basically 8 here you see 8 sections in this wall, and we had always one section of each insulation material with without, and one section with fold, so with a hole in the inner layer, in the airproof layer. So we made some holes just to check if the constructions will tolerate these holes, if they will work still, even with some if there would be a damage by the user afterwards, if they make a hole in the inner layer, if it still works or not. And yeah, from the inner side, it looked like this when we did finish the wall. And we did the measurement for 18 months. And we used quite high humidity inside, like 60% permanently, and for a short term also up to 100% relative humidity, just to examine how the humidity inside the constructions will behave. And also some overpressure tests that even more air is pressed inside the constructions through the holes. And the results did show that, especially for straw and cellulose insulation, the thermal conductivity was even better than it should be if you consider the 20% moisture surcharge. So in the case of cellulose, the measurement was 10% better. In the case of straw insulation, it was 7% better. And for sheep's wool and mineral wool, there was no change visible. So in this case, we can say for our measurements, it was just one measurement for 18 months, but all in all, we can see that the thermal conductivity, that the 20% moisture surcharge is too much in that case. So in these two cases, it would have been maybe a 10% moisture surcharge enough. So that's one more result. And on this, we should continue our research just to prove that these results are also good if you do it more times, not just one time. And similar measurements have been done in the other research project to present now, which is the ThermNat project. This was also a quite big research project with many companies involved and also many research institutions involved. There was also the Fraunhofer Institute involved from Germany and Volkswagen Austria and some others. Here the measurements were done on a research house in Austria, in Stetten, by Volkswagen Austria, what you can see here. And in this house, in 2 sides and 2 facades, there were inserted several small sections of different insulation materials, like mineral wool, wood fiber, cellulose, sheep's wool, and straw, and also different insulation system outside. So we had you can see it on the next slide. We had insulation between wooden beams, and we had ATIX insulation system outside, or a ventilated insulation system outside. So it was a more complex construction than in the Natureplus project, but similar insulation materials that were examined. And here you see just the different types of constructions that were examined, also with different colors of the plaster outside and different inside layers like OSB board, or there was also some, you see here, MDF board, for example, and also different densities of the insulation materials, of the wood fiber insulation. So there were many different constructions examined, and they were measured with temperature and humidity sensors on the inner side and on the exterior side, and if there is an ATIX also behind the plaster. And the air temperature close to the surface was also measured inside and outside. The results of this project show that in this case here the result is shown like a deviation of the measured value to the expected value. And if there is a plus, it says that the measured value was 3% higher than the expected value. But this expected value does not consider the moisture surcharge yet. So here we can say we have a moisture surcharge in every case of less than 20%, except for this one case of cellulose insulation. But there, in the end, it was examined that the density was too high of this insulation, so it was not blown in properly. That's why the thermal insulation value was not so good like it should be. So this is not due to the that the moisture surcharge is so high that it was not blown in properly. So we should watch on the other numbers, and here we see in this case of straw insulation we have even a negative moisture surcharge. So the thermal insulation of the construction with straw insulation was better than it should be according to the declared thermal value. So the design thermal value in this case was better than the declared value. No, not the design value, but the measured value. Here one more time the results. One more result which was interesting was that the wood fiber ATIX was less critical than the EPS ATIX, because the wood fiber ATIX is more open to diffusion, and so the humidity value or humidity level inside was lower than in the EPS ATIX. And usually the climate is not so critical like the 80% relative humidity that is given in the standards. So we have to calculate the insulation properties of the wall with 80% relative humidity value, which is in the practical case, in the real case, is rarely happening. So just in the outside layer of the EPS of the ATIX, the plaster, we can have such high humidity levels, but in the inside, usually the humidity is maybe about 50–60% and not higher. So one more reason why it might not be necessary or might not be so realistic to calculate with that high moisture surcharge.
So one more reason, one more doubt about this 20% moisture surcharge. We also talked with the Austrian Standards Institute, with someone responsible from there. Why is this moisture surcharge so high, and how can it be changed maybe in the future? And the answer was that, yeah, it is high, but you don't have to use it. If you can prove it's better, then you can use the better value. So in the case of bigger companies that can afford the test to test the design value, then they might be able to prove it's not 20%, it's just 5%, for example. Then they can write it on the data sheet of the insulation material. But for smaller companies which cannot afford this test for every type of insulation that they sell, they have to then they have to use this 20% moisture surcharge. So yeah, we still want to find a way to change this in the standards, but to be able to change this, first we need more research results that show that this is not justified. And to get these research results, we want to continue the research on this topic, and we want to start at the moment 2 more research projects in this field. And I want to show you what is our idea for these research projects. The first one is a research project that we want to do together with Holzforschung Austria and Fraunhofer Institute of Technology. And we also want to include the Austrian, the OEB, the institute that is responsible for the Austrian construction laws, and Ecolab, which is a labor that is doing the measurements for us. And we want to test again a big range of insulation materials, of natural fiber insulation materials on the one side in our exterior test stand on Arsenal, as well as on the research house in Stetten in Austria. So we want to use both houses, but we have enough space for about 30 or 40 constructions that we want to test there. And we want to make more measurements to show the thermal insulation properties of these natural fiber insulation materials. So we will do some long time measurements again for at least 1 year, and also some durability measurements in the labor to show if these natural fiber insulation materials are also durable in very humid condition, if they will decompose or not, or how fast they will decompose. So we are doing these tests on the one side on Holzforschung Austria, that they will do some tests in their house. We will do tests in our test stand. The Fraunhofer Institute for Building Physics will continue this transient prediction model for destruction of natural fiber materials by decay fungi. So that's what they did develop, and they want to extend it for more natural fiber materials, because now it's just available for two or for some few different materials. And together with the OEB Institute, we want to find a way to bring these research results also into the standards, the Austrian standards, and so that maybe in the future, after this research project, there will be the possibility to change this moisture surcharge in the standards. That's why we also include them, and the Ecolab that is doing the measurements, which is also approved by the OEB Institute. And then, last but not least, we want to start a research project on the renovation topic of Wilhelminian-style buildings, Gründerzeitgebäude, in which we have quite many in Vienna and in Austria. And the reason is that we see that there are so many buildings from the from this Wilhelminian period which are not insulated, and people say, or many people want to insulate them, but it's difficult, and you don't know how to do it. And if they are insulated, then usually with APS, which with synthetic insulation materials, which do not fit to the materials that have been used in these buildings. So we the buildings from that time are very ecological, basically. From the material part, they consist just of some few materials. They can be deconstructed quite easily, and then if they are renovated, we glue APS insulation on the facade, which cannot be removed afterwards. So we are gluing some not ecological material on a quite ecological building, and we make a material compound that cannot be separated anymore. So that's it's nowadays a standard, but it's the wrong direction. It's not the way that these Wilhelminian style buildings should be renovated. So we should find now some solutions to renovate them ecologically, because we have so many of them. We have a quite high building stock of Wilhelminian style buildings in Vienna, and we need some ecological solutions that will not destroy the ecology of our building stock, basically. Yeah, here some more information about the current status. So how many buildings in Vienna we have from this period? It's almost 20% of all buildings, and at least 40% of them are in urgent need of renovation. So if you renovate them, we need some ecological solutions now, and yeah, we don't have so much time to waste in this case. And the refurbishment rate is very low at the moment, which is also a problem. So we need solutions for fast and ecological renovations in Vienna and also in other cities in Austria and maybe in whole Europe. Our idea is again a FFG research project, so funded by the Austrian Research Promotion Agency for 2 years, and we want to focus on multi-story Wilhelminian style buildings and find ecological solutions for the renovation. And here we take into account the statics topic, the building services topics, and the topics of ecology and economy. So they should also be not too expensive, of course, because nobody will do it if they are not affordable. And they should fit to the aesthetics of this period. So we don't want just to glue something on the facade and make a flat facade. If we had before a very structured facade, a beautiful structured facade, we want to keep this aesthetics of the building. Yeah, it should look it should fit to this style, and and we need solutions still to insulate the facade without just gluing something over it. Yeah, here I did write it again. So basically I have said most of it already. One thing that we want to focus on is the renovation of the exterior walls that are in contact with the ground. So we need some solutions to make them waterproof, for that the cellar will get dry, that there will be no wet walls, that we have that the water is rising up the walls. So we have to find some solutions which should also use just ecological materials, and we are thinking, for example, of clay, which can also protect the exterior walls from water, because clay can be used as a Abdichtung, so it can prevent the water from getting to the exterior walls, to the ground walls. So the team will be similar, but we also have already contact with experts in the field of Gründerzeit, of Wilhelminian style buildings. Like Obkircher, for example, is a company that is doing already many refurbishments of Gründerzeit buildings, and Vincent Hara GmbH, so some companies that are already executing these renovations, and they already have some experience also with ecological building, so they can help and bring in a lot of expertise in this field. And yeah, the other partners are basically from the Natureplus consortium as well. So that was a small outlook of what we are planning to do in this field. And if there are now any questions about this, I'm happy to assist. Thank you.
Thank you also from my side. This was really interesting what Austrian Standards Institute is saying. So if you want to play with us, you have to use our rules and make the certifications, the measurements to prove that the natural materials are also able to fulfill the requirements. Before we start the discussion, I just want to say thank you, of course, Florian Teichman, but also what I forgot to mention is not only our sponsors, Isolena Berg & Berg and the Federal Association of the Wooden Windows, but also this series is part of the project Umbauwende, and it's funded by the German Federal Ministry of Environment and also from the German Federal Environment Agency. So thank you that this is possible.